The aims of this guidance are firstly to bring greater coherence to the national curriculum by exposing core concepts and demonstrating their progression from year 1 to year 6, and secondly to summarise the most important knowledge and understanding within each year group and important connections between them. This video guide summarises the knowledge and understanding that year 2 pupils need to achieve by the end of the year in order to be ready to progress to year 3. There are accompanying materials which provide teaching guidance for each ready to progress criterion and example assessment questions. And we recommend that year 2 teachers should read the guidance for both year 1 and year 2 so that they understand the starting point of year 2 pupils. In year 2, pupils must be taught to connect the way that 2-digit numbers are written in numerals to their value. This is the number 23. The 2 shows we have 2 groups of 10. The 3 shows we have 3 extra ones, and they must be able to do this when the position of tens and ones manipulatives is reversed, or when the tens and the ones are presented randomly. Pupils must understand that 23, for example, can be composed of 23 ones or of 2 tens and 3 ones. And pupils should know that they can group objects into tens and count the number of tens and number of ones to enumerate the objects in a large set. Once pupils have understood the composition of a number in terms of number of tens and number of ones, they should be able to apply this understanding to solve addition and subtraction calculations, which involve standard partitioning. Pupils should become familiar with seeing 0 to 100 number lines, and they should be taught to place numbers 0 to 100 in the linear number system. They should be able to identify numbers on partially labelled number lines using strategies other than counting forward in ones. For example, identifying that this number is 36 because it sits one more than the halfway point between 30 and 40. Or that this number here is 79 because it is one less than 80. Pupils should also be taught to estimate the position of numbers to 100 on unmarked number lines, like this one. Teach pupils to mark the midpoint of number lines to help estimate the position of numbers. For example, 60 sits roughly here relative to 50 and 100. And positioning numbers in the number system prepares pupils for working with scales on measuring instruments or charts and helps children compare numbers and make estimations. So pupils will leave year 2 understanding these 2 models of 2-digit numbers. Number as enumeration, which is the cardinality of the number, and number as measure, which is its place in the linear number system. In year 1, pupils learnt addition and subtraction facts within 10, and pupils must continue to practice these facts in year 2 so that they're able to recall facts fluently and apply them to 2-digit calculations. Year 2 pupils should learn to add and subtract across 10. They should use tens frames and partitioning diagrams to understand how to do this. To add 7 and 5, we partition the 5 into 2 parts. 7 and 3 make 10, and 2 more make 12. 7 plus 5 is equal to 12. To subtract across 10, pupils should use one of 2 alternative strategies. In the subtracting through 10 strategy, we subtract the subtrahend, in this case 9, in 2 steps. First subtracting 5 to give 10, and then we still have 4 more to subtract, which leaves 6. 15 minus 9 is equal to 6. In the subtracting from 10 strategy, we partition the minuend into a 10 and a 5, subtract the 9 from the 10 to leave 1, and then put the remaining 1 and 5 together to make 6. 15 minus 9 is equal to 6. So these are the 2 strategies for subtracting across 10 side by side, subtracting through 10 and subtracting from 10, and both show that 15 minus 9 is equal to 6. In Year 1, pupils met the additive structures of aggregation and partitioning and augmentation and reduction. To be ready to progress from Year 2, pupils need to be able to solve questions such as there are 5 red cars and there are 3 blue cars. How many more red cars are there than blue cars? This is the difference structure where two quantities or measures are being compared. And pupils should be able to solve difference problems phrased as find the difference, or how many more, or how many fewer. And they should relate them to either a missing add-end equation or to subtraction, applying known facts and strategies. In Year 2, pupils must also learn to apply addition and subtraction facts within 10 to units of 10. Because 4 ones plus 3 ones is equal to 7 ones, we know that 4 tens plus 3 tens is equal to 7 tens. And equally, we can subtract either of these parts using known facts. So 7 tens minus 4 tens is equal to 3 tens, and 7 tens minus 3 tens is equal to 4 tens. Working in a unit of this way, in this case a unit of 10, is called unitizing. Pupils must learn to use this knowledge to solve addition and subtraction of two-digit numbers. Pupils can use the knowledge that 4 plus 3 is equal to 7 to solve calculations like 40 plus 30 is equal to 70. And pupils can use their knowledge of number facts within 10 to solve calculations involving the subtraction of a multiple of 10. 7 minus 3 is equal to 4, so 75 minus 30 is equal to 45 because we're subtracting 3 tens from 7 tens. The range of calculations that pupils should be able to apply their knowledge of, for example, 4 plus 3 equals 7 to, is shown here. So adding and subtracting multiples of 10, adding a multiple of 10 to or subtracting a multiple of 10 from another two-digit number, or adding a single-digit number to or subtracting a single-digit number from a two-digit number. Pupils must also be able to subtract a single-digit number from a multiple of 10 by using complements to 10. So 10 minus 3 is equal to 7. And therefore 30 minus 3 is equal to 27. Pupils also need to be able to add both multiples of 10 and single-digit numbers all together. Pupils need to be able to identify the multiples of 10 and add these, and then add the single-digit numbers. They then have the requisite understanding to add two two-digit numbers by partitioning into tens and ones parts. Place value manipulatives, such as Deans, expose this structure for pupils, and pupils should be able to use place value equipment to explain how to add two two-digit numbers. 40 plus 20 is equal to 60, 5 plus 3 is equal to 8, and 60 plus 8 is equal to 68. To be ready to progress to Year 3, pupils need to be able to use their own jottings to solve calculations such as these, without relying on manipulatives to help them get an answer. Pupils also need to be able to subtract from a two-digit number. So pupils should be able to partition the subtrahend and then subtract both these parts in turn. So let's look at that now. 45 minus 20 is equal to 25, and 25 minus 3 is equal to 22. So 45 minus 23 is equal to 22. In Year 2, pupils should be taught to relate equal group contexts like this one to multiplication and division. Pupils can already write repeated addition expressions, for example 5 plus 5 plus 5 to represent this context. In Year 2, they must be taught to write multiplication expressions to represent the same context and relate the terms to the context. So in 3 times 5, 3 represents the number of groups, and 5 represents the number of eggs in each group. Pupils must be able to understand equivalence between a repeated addition expression and a multiplication expression and write and complete similar equations. Pupils should also learn to calculate the product of repeated groups of 2s, 5s or 10s, initially by skip counting. 5, 10, 15. 3 times 5 is equal to 15. Pupils should be able to relate multiplication to situations where the total number of items cannot be seen, for example, by representing 3 times 5 with 3 5-value counters. Pupils should be able to solve multiplication equations presented without a visual prompt, and they may skip count on their fingers, or they may draw their own simple groups of 5 picture to help calculate this. 5, 10, 15. 3 times 5 is equal to 15. Pupils need to be able to find the number of groups needed to give a particular total to solve multiplication equations with missing factors. For example, there are 15 biscuits. If I put them into bags of 5, how many bags will I need? And that can be represented with this equation shown. So pupils can use skip counting or their emerging 2, 5 and 10 multiplication table fluency to calculate the missing factor. 1 group of 5, 2 groups of 5, 3 groups of 5 is equal to 15. Pupils also need to be taught that dividing a total into equal groups can be represented with the division equation. 15 divided into groups of 5 is 1 group of 5, 2 groups of 5, 3 groups of 5. 15 biscuits divided into groups of 5 is 3 groups. Pupils also need to be able to solve division calculations that are not set in context, and they should recognise they need to skip count in the divisor, so 2, 5 or 10, or use the associated multiplication fact to find the quotient. So to calculate 15 divided by 5, pupils can skip count in 5s, 5, 10, 15, to see that there are 3 groups, or they can apply the fact that 3 times 5 is equal to 15. To give the answer of 3. In geometry in Year 2, pupils need to handle a wide variety of common 2-dimensional and 3-dimensional shapes. Teach pupils to identify faces, edges and vertices in 3D shapes and sides and vertices in 2D shapes. And pupils must know that a polygon is defined by its number of sides rather than whether it looks like its image of a particular shape. So, for example, although pupils may informally describe this as being like a square with 2 corners cut off, they should recognise that it's in fact a hexagon because it has 6 straight sides. And as well as identifying and counting sides and vertices, which are precursors to perimeter and angles, pupils should also reason about the space inside a 2D shape as a precursor to area. They should reason about the shape and size of polygons relative to one another. But as children do not yet have techniques to measure this space, their descriptions will necessarily involve informal language. For example, they may describe shape F as being like shape A, but stretched out so that it's longer than A and therefore is larger